Please remember there are additional resources and things such as code samples at elithecomputerguy.com. So if you're watching one of these classes and you need to know what code looks like, or if you need links to the resources that we're using, please go to elithecomputerguy.com and take a look at our class posting there. Also, please remember that free to the end user classes are not actually free. It costs me a lot of money to be able to provide this type of content. So if you could click on the donate button and throw in a couple of dollars every month, this will help me be able to continue to provide you this type of material. Welcome back. As you know, I am Eli the Computer Guy. I'm joined today by my assistant instructor, Peanut the Wah, and we are going to be learning about modules in Python. So we're well into the series learning how to program in Python, and I really haven't gone over modules a whole lot because I want to give you a basic foundation on some of the simpler concepts in the Python programming language. The idea of variables and concatenations, if-else statements, loops, those types of things before we jump into modules. Now, if we want to do anything more sophisticated than what we've done up until this point, we are going to have to start using modules because in the Python world, everything is a module. If you need any function whatsoever, it's going to be in a module. You are going to have to import that module into your code before you were able to use it. So if you're used to other programming languages, again, a lot of times I talk about PHP, there are a lot of functions, actually very powerful functions that are built into just plain PHP. You can access them at any time. If you want a random number, you just ask for a random number. If you need the time, you just ask for the time. If you need to send an email using SMTP, there's a mail function to do that. And it's all just right there. You tippy-tap type out that PHP code and you're sending emails. When you get in the Python world, did you import the module? Literally, if you want a random number, you have to import the random module to get a random number. If you want the time, you have to import the time module to get the time. If you want to be able to send commands at the OS level, you have to import the OS module in order to be able to do that. So one of the big issues that you run into when you're a new person learning how to do Python is simply what module do you need? Like, no, serious, I just need a random number. I just need like a random number between like 0 to 10. That's all I need. And you're going to get to go and do a lot of research. Now, this is actually a valuable thing in the Python world, and one of the reasons why it's so valuable is that you can manually add packages into your Python installation. So basically, there are a lot of default standard modules that come included with Python. Again, time, date time, random, those kind of modules that I've talked about. When you install Python or when somebody else installed Python onto your system, those modules are already there. But one of the nice things with Python is you can continue to add modules. If you need to use artificial intelligence with OpenAI, you can install the OpenAI module. If you want to be able to parse RSS feeds, you can install an RSS feed package or module relatively easily. And so basically with Python, what's really nice is although you have to write out every module that you want to use, it actually makes it a lot easier at the end of the day to be able to add a lot of functionality to your Python code relatively easy. The other thing with this is it's also good from a security standpoint. So imagine if a hacker is able to compromise your PHP code or some other type of code that you have on a server. There's a concept of basically injection attacks, essentially being able to inject commands or whatever into the code. Well, one of the things with PHP and other programming languages is that a hacker may be able to access higher level functions on that server because functions and functionality are already built into the code that's been created. And so if they can kind of tweak that or inject something in there, they may be able to compromise the server. One of the nice things with Python is you literally do not get access to a function that you have not explicitly imported into your code. So again, it's that whole vulnerability, right? Threat vector when you're looking at cybersecurity. If if your code has no ability to perform certain actions, even if a hacker compromises your code, they're not going to be able to do very much because your code can't do very much. So that's one of the things to be thinking about with the Python world. Again, there's pros to how they deal with modules. There's cons to how they deal with modules. But as I tell all the noobs out there, it is as it is. They're like, Eli, do you agree or disagree with how Python was designed? And I just look at the noobs and I'm like, it's how Python was designed. I didn't get a vote in this argument. Just accept it as it is. So now, as we're talking about modules within Python, we need to go over pip. So this is the package manager that is the default standard when you're going to be using Python. Now, there are other package managers out there that you may run into, again, with a legacy system, or there might be a requirement that you use it for some reason. But in general, again, for educational purposes and most purposes, you are going to be using pip as the package manager. Now, when you sit there and you take a look at pip and you're wondering, I wonder what pip means. Basically, what pip means is pip install packages. So PIP stands for pip install packages, and this is one of the times when I kind of get frustrated at my particular career field. It's kind of like GNU Linux, GNU Linux, GNU, not Unix. And it's like the name of the thing is in the name. And you're just like, oh, geeks are so passive aggressive. They're just so passive aggressive. Anyways, when we're dealing with pip, you'll notice up here, I have the differentiation between pip and pip3. Now, as I talked about before with Python, do remember there was a version of Python called Python 2. We are currently using Python 3. Now, there is a hard fork between Python 2 and Python 3, and Python 3 code will not run on a Python 2 interpreter, and Python 2 will not run on a Python 3 interpreter. Now, if we were in a sane world, everybody would simply be on Python 3, and we wouldn't care about Python 2 anymore. But, well, we're not in a sane world, right? So Python 2 was supposed to die a long time ago. It was supposed to die back in like 2010 or something like that. And then they kept it on life support, kept it on life support, kept it on life support, kept it going, and they finally killed it, 2021, 2022. Basically, when they killed it, though, the important thing to understand, that just means they're no longer updating it anymore, and they're no longer pushing out security updates for Python 2. That doesn't mean you don't necessarily have Python 2 running in your infrastructure. Have fun with that, right? So the issue that we get into is pip. So the package installer. Pip generally is for Python 2. That was the original pip. And then pip3, the idea is that's for Python 3, right? So if you're going to install a package into Python 2, you wouldn't use pip. And if you're going to install a package into Python 3, you would install pip3. The thing is, Python 2 is supposed to be dead. These are really just names. So at the end of the day, when you type in pip, if you type in pip, it might trigger pip3, and so you will install the Python 3 module into Python 3. Or you might type pip, and it'll trigger Python 2, and it'll try to install the module for Python 2. That can be a bit of an issue for you. Or, depending on your distribution, if you simply type in pip, it may literally just do nothing because it only recognizes pip3, right? One of the frustrating things. So in Ubuntu, I always basically have to use pip3 in order to get pip to function properly. So if I do pip install, pip list, pip uninstall, I'll always use pip3. Again, the demonstration computer that I'm using for a lot of these classes is an M2 MacBook Pro. So we're using the Mac OS, obviously. With Mac OS, you can use either pip or pip3 because Python 2 is supposed to be dead, and so Mac OS just defaults everything to Python 3. Again, I don't know your distro. I don't know your environment, so I'm not actually sure which one of these you should be using. So basically, if you try to use pip and it doesn't work at all, use pip3. If you use pip and it seems like it works, but then when you go to access the modules in your code, it doesn't work, then it might have installed into Python 2. So use pip3 to install or do whatever else instead and go from there. And then basically just, kind of keep this in your brain. You may have to install pip. So pip may be an additional thing that you have to install onto your computer. So again, like with Ubuntu, Ubuntu has Python 3 installed by default. It does not have pip installed by default. So with Ubuntu, it might be sudo apt install python 3 - pip, and that should install pip for you, hopefully. Right? Then when we go to install a module, basically all the command that you have to do is pip3 install whatever the module name is. So basically with this, when you run pip3, it is going to access pypi.org, pypi.org. So this is a repository, right? So with Linux, where you can do sudo apt install, and basically it'll just pull down the files for the application and then install it for you. The same thing is true when you use pip. Basically, pip is going to come up to pypi.org. It's going to find one of the $500,000 projects, the packages that are up here. It will then download that onto your computer and it will install it for you. And there you go, right? It'll be pretty simple. In order to install, you simply do pip3 or pip. But for safety's sake, while you're learning, just use pip3 right now. Pip3 install, and then whatever the module name is. So we go over here to the command line. Let's see here. I can hit clear the screen, and so I can do pip3 install and then OpenAI, right? So OpenAI has a package. If you want to put quote unquote artificial intelligence into your Python code, you can do it. You hit enter and it'll probably find that actually already has it installed here. If you go through this normally, you'll see that it'll say download, download, download. Again, that's an important thing. It's downloading from the internet. So if you don't have internet access, that's not going to work for you. It's going to download and then it'll install. You can install Python packages manually, but we're not going to get into this class today because most people are not going to be doing it, and it's just a little bit more additional confusion. Now, it is important to understand there is a difference between pip3 install and the module name or the package name versus sudo pip3 install the module or the package name. This can get you into trouble. When you do pip3 install, this will install that package, right, for the normal users of the computer. So you install OpenAI, and the normal user accounts on the computer will have access to the functions within the OpenAI module. If you do sudo pip3 install, it means the sudo users will have access to those Python modules. So generally, you're always going to want to do pip3 install module, right? So a lot of times we're used to using sudo to install things using Linux. So it seems very natural to use sudo to install things using pip3. If you do that, you may run into a problem where you've technically installed pip3, but your users don't have permission to deal with the module, and everything kind of goes to hell. There's a reverse true. So I'm actually building a robot. I don't know, if you're following me in real time, you'll know I'm building this little computer vision robot thing that's being driven around. Anyways, interesting thing that I found with that is I use the OpenCV. So OpenCV is a computer vision framework that you can use with Python. And so the interesting thing, so I did pip3 install OpenCV. I'd installed it. The tracking, X, Y coordinates, all of that stuff is working properly. And then I added a drive subsystem. So basically I have a USB cable connected from the computer on my little robot that goes down to an Arduino, and the computer sends serial commands down to the Arduino, and then the Arduino turns the motors on or off for the robot. What I found was interesting is the normal user does not have permission to connect to the USB port using serial communication. You actually have to run the Python script as sudo. Well, here's the thing. I installed the PySerial, so it's called PySerial module. That allows you to communicate over serial communication. So I installed the serial module using pip3. I then went to run my script as sudo. But sudo didn't have that module installed. The normal users had that module installed. So I then had to do sudo pip3 install PySerial in order to get it to work to work properly in a relatively easy fashion. There's a better way of doing that, but that's actually a real world example of I had to run the Python script at a higher level permission, at an escalated permission level, but that escalated permission level did not have access to the packages that had been installed, so I then had to install the packages using sudo. So again, it's one of those things. Most of the time, you're just going to do pip3 install, whatever the package is. Again, if you have to run at those higher level permissions using sudo, you may have to do something else. Just one of those things to keep in mind. Past that, we have pip3 list. So if we come here and I do clear, pip3, oops, 3. List will show us all the modules that are installed, or all the packages that are installed onto this particular computer. So a lot of these, again, are just default packages. You get a lot of default packages already installed, and then there are additional ones that I've installed. So I know on this computer, I've installed Beautiful Soup 4 of a particular version. If I come down, there's Feed Parser. So this allows us to parse RSS feeds. You can see I have version 6 here, and you can just scroll down to see if a particular module is installed. So again, I was just talking about the PySerial module, PySerial module. So if I was going to try to run that script onto this computer and I was auditing the computer beforehand, what you should do, I could come here and go, okay, PySerial is not installed onto this particular computer. Again, what is the process for getting the module installed or whatever else? So that's just a basic way to see the list of the modules that are installed onto your computer, or the packages, right? Past that, you can then uninstall. So if you don't want a package anymore, pip3 uninstall, let's say OpenAI. So I go across. We do the clear again. Oops. Hey, I don't need a dog barking during a class now, do I? So I can do pip3 uninstall OpenAI. I can hit enter, and found existing, uninstalling, would remove, yes. So we say yes to it. Successfully uninstall, right? So if you want to uninstall one of your packages for whatever reason, that's all you do. Pip3 uninstall and whatever that package name is. Again, it is something to think about, especially with a production server. Kind of keep it clean. Basically, the more packages that you can eliminate, the less vulnerability your server will have. The final thing that I want to talk about down here is the difference between pip3 install, package or module, versus apt install, the application. So you may run into this sometimes. I've run into this with Django. So Django is the web app framework that I like. We're going to be doing a lot of classes using Django. And when I put Django onto an Ubuntu system, I do apt install, whatever is Python 3-Django or whatever the command is, right? So supposedly, when you look at the instructions, it says to use pip3 install Django or whatever the name is. If you do that on Ubuntu, it just fails. You don't get the web framework in a fashion that'll actually work for you. You actually have to do apt install and go from there. And so this is one of those things, again, your distribution, your environment, what you're dealing with. I've had to deal with this before, again, with OpenCV, computer vision. Technically, you should be able to install OpenCV through pip3. Sometimes with whatever it is that I'm doing, it doesn't work properly. So I do apt install OpenCV, install it onto the operating system, and then I have access to the things that I need. Again, which is the right way to do it? It depends upon your particular situation. By default, try to use pip3. This is the standard way of trying to install things that you're going to be using for Python. If that doesn't work for whatever reason, you might have to try apt install and actually install the framework, whatever you're dealing with, onto the operating system itself. So yeah, so this is a brief overview What pip is, again, you may have to install pip. When you use pip, generally just use pip 3. You might have to you might use pip, but pip 3 install module name to install a module name, pip 3 list to list all your modules, pip 3 uninstall to uninstall a module, and then again, like I say down here, especially when you start working with more complicated projects, you may actually have to install the framework or whatever you're dealing with directly onto the operating system, and that's something we'll go over in classes in the future. Danger, Will Robinson, danger. So before we actually get into working with modules, I do want to go over security for a second because this is a damn disaster in the Python world. So it's kind of funny for somebody like me. Again, I got my MCSE back in 2000, right? Been doing tech since 96. So the definition of words has kind of changed over time, or the full meaning of words has changed over time. So like when we talk about open source, right? When I think about open source, I think of entire products. Like MySQL is open source. Linux is open source. OpenOffice or LibreOffice is open source, right? And basically, if I'm an administrator or if I'm a decision maker, the question is do I trust this entire product within my environment? Right, and then what are the security, procedures that we do to make it more secure and the whole 9 yards. One of the interesting things with open source in the modern world is that people are no longer dealing with full products, again, like operating systems and database systems and that type of thing. Many times with open source, they're basically using simply open source Python modules. So you come to me, you hire me to build your company an app, and within that app, there might be 20 open source packages or modules that allow me to do whatever it is that I need to do. Again, beautiful soup that allows you to parse web pages very easily. Feed parser allows you to parse RSS feeds very easily. And basically, you just type in, pip3 install, whatever the package name is, and you download it and you install it. But here's the thing. Anybody can upload to py.py. So packaging Python projects, if you scroll down, one of the things that you'll notice here that I've highlighted, when you're naming, when you're naming the package that you're going to upload, this can be any name as long as it only contains letters and numbers. It also must not already be taken on py. Why I point this out is basically anybody can upload a package to py, and then anybody can download the package from py regardless of the quality. Nothing makes you respect the Apple Store, the Apple App Store, just a little bit more than when you use something like py.org, because what you realize is that there's not very much moderation. It really is buyer or user beware. So one of the interesting things is that there was actually a hacking vector where what hackers would do is they would create compromised packages, and then when they upload them, they would make the name similar to a well-known package, just with like 1 or 2 letters off. So again, if you're typing in Beautiful Soup 4 really quickly, you might forget the E, or you might miss the U or whatever else, right? There's common typos. So they would upload compromised packages that are named with basically common typos in them, so that you download, install the package, and your system gets compromised. I think about this with something from the war that's currently going on in Ukraine, right? So when the war in Ukraine started, you had a hacktivist out there that had created a Python module that a lot of organizations were using. And so what he decided to do is he made an update to that module, so the module would detect the external IP address of the server it was running on. It would then geographic check where that IP address is located. And then if it was located in Russia, it would delete the server. That is a real world. That is not a bedtime story for kids. That is not only what somebody did, that is what somebody felt very self-righteous to do which is a hell of a thing. So when you're installing these modules into your projects, you really have to be careful. Again, I've talked about this before with cybersecurity. Cybersecurity is about creating layers of security. So even if one or multiple layers are completely compromised, your systems are still okay, right? If your database is on the exact same server as the Python script, and the Python and a module in the Python script basically says to reformat the drive, then your database is gone, right? But that's not a good way of building infrastructure, as good architecture. Your database should be on a database server. Your Python script should be on a different server. So even if the module basically deletes the drive that the Python script is on, your database is going to be fine because it's on an entirely different server. Right? This is one of the things that you have to think about when you're going to be building projects. One of the sad things that I found with a lot of coders in the modern world is they literally don't know what architecture is. And that's scary. I had one of my students that was a professional coder, and I was talking about architecture or something one day, and he was like, "Yeah, Eli, I don't understand architecture." And this is a professional coder. This is a professional coder making money coding the real world. And I looked at this person. I was like, "Oh, okay. So what? Service-oriented architecture, a microservices architecture, serverless architecture. Which architecture don't you understand?" And they just very innocently looked at me and said, "I don't understand what you mean by architecture." And I was like, "Oh my God, this is so bad." And the worst part is, I bet there's a lot of coders out there that don't really grasp the concept of architecture. So anyways, if you're going to be a good coder, understand what architecture means, because again, if you're going to be installing these modules into your system, you really have to think about, what if that module was 100% compromised? What if that module was 100% compromised by, a state actor that hates the country that you're in, and so they're going to go in and they're going to do the most damage possible? You should design your systems so even if one of those persons is able to infiltrate your system, there is very, very, very minimal damage that could be done, right? So anyways, again, anyone can upload to PyPy. Again, I've talked about this many times. Distrust, verify, continue to be suspicious. There's this whole trust but verify. Again, like the security world or whatever, they talk about that. Trust but verify. And I'm like, that's dumb. Why would I ever trust anybody? That starts from the wrong mentality. Don't trust anyone ever. Distrust and verify and continue to be suspicious. And again, when you're building, like I say, with architecture and all that, build for that zero trust environment. So even when, let's just put it that way, even when a compromised module is put into your code, doesn't really matter that much. So now we actually get to modules and functions and how to use them in our code, which again is actually relatively simple. Again, one of the big things in the programming and the technology world is many times it's the philosophies, it's the ideas behind things that are actually pretty complicated and time consuming, and tapping out the code actually is the easiest thing that you're going to do. So anyways, so this is a bit of code, and all we're going to do with this bit of code is we are going to print out a random number. And again, as I've talked about before, even if you want a random number, you still have to import a module. So the first thing that we're going to do here is we're going to import a specific function from a module. So again, the more functions you have in your code, the more functions that are imported, the more vulnerability your code has. So really, if you really want to be secure, you only want to import the exact functions that you're actually going to use. Now, spoiler alert, that's probably a bridge too far for most people, but that's what we're trying to go for. So anyways, what we're going to do here is we're going to say from, and then we're going to say the module that we're importing from. So from the random module, we are going to import the randint function. So module function. Then we're going to have number. So number is going to be a variable. We're going to set the variable value to equal randint. So again, remember with randint, an int is a whole number, a float is a decimal point number, so this is a whole number. Randint, parentheses, 0, comma 100. So what this does is it gives me a random integer between 0 to 100, and it will set the value for the number variable, and then we will print that out. I go up, I hit the run button, and then as we can see, I get the number 64. I do it again, 25, 7, 34, 25, 12, so on and so forth. So again, this is all pretty simple. Doesn't really matter a lot, but this is going to be one of the standard ways that you're going to be importing functions into your code. Is the function is within a module. So from module, import the specific function that you're looking for. Now, if you need to import multiple functions from one module, all you would do is comma, space, and then whatever the additional modules are. So if there are other random or additional functions are. So if there are additional random functions that you want out of the random module, you would do comma, the next function, comma, the next function, comma, the next function, and then you're simply able to access it with the randint. So in the previous example, I imported a single function out of the random module. Now, what if we want to import the entire module, all the functions that are in that particular module? Basically, the way that we do that is we simply say import the module, and from there, we will get access to all functions within that module. We basically have the exact same code we had before, number equals. Now what you'll notice though, instead of simply being randint, we say random.randint. So we imported the entire random module. So we're going to call the random module, and within the random module, we're going to call the randint function, 0 to 100, and then we're going to print out that value. So if you're doing it this way, where you import the entire module with import module, you would do module period function, and that is how you would get whatever functionality is that you're looking for. Again, if we go here and we hit run, 88, 43, 86, you get the point. We get a random number here. So this is another way that you're able to import, but this is doing the entire module. Now, this is the way that you're not supposed to do it. Though, of course, in Python, sometimes it's the way that you have to do it. Anyways, so let's say you want to import all the functions from a module, and then you simply want to be able to call them by the function name, right? So basically, if we go back here to this script, we said from random import just randint, and then we're able to call randint. In the next example, we imported the entire module, but every time we need a function out of that module, we have to call the module period and then whatever the function is. One of the things that we can simply do is we can use the star wildcard to say from random import all functions. So this will import all functions from the random module. And then when we want to access any of those functions, again, imagine it's just this star is the equivalent of function, comma, function, comma, function, comma, right? Basically all of them. So we can simply call just randint 0 to 100, and then we're able to print out the number. So this is generally frowned upon because you can run into namespace issues. So when you have like functions here, right? If you end up having two functions in your code with the exact same name, again, imagine you import a couple of modules and you do this import all, and they're open source modules, and the developer really wasn't thinking about functions or whatever else, function naming conventions. One of the problems you might run into is one module has a function of a specific name, and then another module has a function of the exact same name. You call a function and you do not realize that there's going to be a naming error there because the Python code isn't going to know what to run. So generally, you're going to stay away from this. I have seen particular circumstances where you actually have to do this to gain access to all of the functions within a module. So that's one of those things you might go to Stack Overflow and you might see, oh, you actually have to do this, for some particular reason. But I just want to show you that this exists, even though you generally shouldn't use it. Now let's talk about aliasing. So this can be important because sometimes basically module names can be really, really, really long. So you're like typing the module name and you're like, crap, I wouldn't want to have to type this 50 times. And then you're like, crap, I'm going to have to type this 50 times. So instead of typing that long name 50 times, you can do an alias and just do the shorter name. So I think about this with like OpenCV. So basically, a lot of times when you look at the code, they'll alias it as CV2. So instead of doing all OpenCV or whatever the module name is, you'll do the module name as CV2, and then you simply call CV2 past that. This is an example, and again, I use stupid name here as an alias just to prove to you. You can call this what you want. So again, import random module as we've done before, but as stupid name, quite literally, stupid underscore name. Number equals stupid underscore name dot rand int, and that's going to get you a random number, right? So instead of calling random here, we're going to call that alias. Again, this probably isn't the perfect example, but you'll see this a lot when you're dealing with modules that have very long names. Aliasing to a much shorter name can make life a lot easier. The other thing with your code, if you're not thinking about the aliasing, when you're going through and you're auditing somebody else's code, you may get confused because there may be an alias in there and you're not sure what that alias corresponds to, and that alias will correspond up to the top, where again some module name has an alias of whatever that is. So that's really all there is to aliasing. Again, pretty simple. So as always, while you're learning to program in Python or anything else, I want you to think about either solving a problem or simulate solving a problem, even if it's a pretty dumb problem, right? Again, remember, technology professionals solve problems with technology. The real skill here really isn't the syntax. It's not the styling. It's not any of that. It's about you learning to look at problems and think about how you're going to solve those problems with Python, right? The best way to do that is to solve stupid problems with Python. And so basically, that's what we're doing here with this code. We are simply creating a pretty crappy little clock. Hey, it's a crappy clock, but it's a solution, right? So if I go and I run this code, just so you see what happens, you see I have the date, and you see every second it updates, and it's a self-updating clock. Yay! Hey, I created this in like 2 minutes before this class began. Okay, so with this, again, just kind of gives you an example of importing modules and then dealing with them. So we're going to import OS. So the OS module is awesome. This actually allows you to interact with the operating system using operating system level commands. So again, making directories, sending ping commands, doing a whole bunch of stuff. If there's an operating system command on your computer, you can actually access that with Python. Today, we're simply going to use it to clear the screen, but we do need it. We're going to import date time. Again, even if we want something as simple as a timestamp, we need to import date time, and we're going to import time. This is going to be for sleep to, again, pause the code for 1 second. And you'll notice how simple this stuff is. So this will just clear the screen. This date time gives me a timestamp. Time allows me to delay the code for 1 second. All those pretty simple things, you need to import a module for them to work. Nice part is all these modules are already installed in Python. So while true, always be careful with this, a while true loop means this will go on forever and ever and ever and ever, right? So we did the loops before, while x is less than, while x is greater than, whatever else, right? A while true loop basically means it's true, always do it. Never do a while true loop with an API call. That was one of the jokes that I always said when I was teaching people, in here in the in-person classes, and they were using my API keys. I would just say, please don't do a while true loop. I don't want to go bankrupt. Because while true loops just keep looping through. They literally never get to a breaking point. So while true, colon. Or while to, whatever. Yeah, colon. Okay, then we indent, as we always do. So the first thing that we need to do is we need to send a command to the operating system. We're going to send the command clear. So basically, we're just going to clear the screen, right? We're going to be printing, and so I want to clear what was previously there. So I call the OS module. Within the OS module, I call the system function, and within the system function, I send the command clear. So that clears the screen, and we go from there. We're going to create a timestamp. So timestamp equals, this is kind of stupid, datetime module, datetime function in the module, and this is a method to turn the datetime into a format that looks pretty. So basically, datetime module, datetime function from the datetime module, the now method to format it properly. Again, we'll talk about this kind of stuff a little bit more in the future, but that just kind of gives you an example. Print what the timestamp is, and then time module, sleep function within the module, so pause essentially for 1 second. And that is how you build a crappy little piece of code. And if we run that, again, from that, we just get this nice little clock that gives you an idea of how these modules and how these functions work in an actual Python script. Now, the final thing to talk about today is namespace. Oh, namespace is brutal in Python. It is brutal. It's one of those weird things. It's one of the few things that causes problems in your code that doesn't necessarily throw a very obvious error. If you forget a colon, you'll get a very obvious error. If you forget to indent, you'll get a very obvious error. If you name your variables or your files wrong, crap happens. So anyways, do be careful about this. So when we're talking about variables, right? So when we create variables, make sure that the variables do not have the same names as functions or modules that you have in your code. Again, that can be a problem, right? If you do from whatever module import all, you're going to import all of those functions. You may not be thinking about it, and when you go to name your variable, you may literally name your variable the same name as a function that's imported in your code. You will get a dumb failure. It may not necessarily tell you what that failure is, so be careful. So basically, when you create a variable and Python is reading through, it's going to then see that if there's a module that's already imported or there's a function that's already been imported, it is going to assume it's one of those modules or one of those functions, and then the code is going to go off the rails past that. The other thing too, we haven't started writing to files yet or reading from files, but when we do, make sure your files are not named the same as Python modules, right? So if you're like, oh, I need to output time to a file, so I'm just going to output it to the time.py file. Doesn't that make sense? Yeah. Your code is not going to work properly, and there's a good chance that the error that you're going to get is going to be a non-obvious error because the people who created Python are a little passive-aggressive. If you are dumb enough to name a file the same name as a module, you deserve this troubleshooting lesson. So anyways, namespace is a big deal. If you're running your Python code, and this is a good thing in the real world of writing Python, right? If you write your Python code and you get obvious errors, fix the obvious errors. If you're running your Python code, and again, you're getting non-obvious errors, like the code obviously is failing, but it's not throwing an error that makes a hell of a lot of sense, I would say go back and look at your variable names, look at your naming convention that you've used in your code, and you may have done something like call variables, a name they shouldn't be called, or called a file a name it shouldn't be called. And so that's, again, it's just one of those things to kind of keep in mind. And the other thing too is when you're writing code, do you remember people may edit your code or improve your code in the future? So when you're coming up with variable names, again, be careful you don't have a variable name that in the future might be used by some module that gets imported later that has a function set that might have that same variable name. So again, it's one of those, as you code in Python, you'll run into these problems and you'll learn how to deal with them. Right now, just kind of keep it in mind. So there you go. There was the class, modules, and Python. Really, using modules and functions in Python is relatively easy. Again, it's a lot of the thought process behind it, and that's where the stuff really gets difficult, and you have to be careful. One of the things, too, I would say do be careful in this modern world with kind of like forum tech support. Because remember, the people in forums might be hackers, right? I always talk about that, where, if I was in charge of the NSA, I would develop the absolute best free VPN service in the world that I absolutely promises you doesn't log anything. Look, it doesn't log anything. We say it on our webpage. That's what I would do. I would also create one of the worst free VPN services in the world. Because, if a VPN service is too good, I mean, there's got to be a scam behind it. So, there's a lot of people that are going to go to the crappy free VPN service because obviously that's not being screwed with by government resources because it's so bad. And then I might have a couple in the middle. Again, you got to think about that with the NSA. The NSA spent 20 years ago, 15, 20 years ago, they spent $8 billion just on a data center to store the data that they were scraping, right? So again, this is one of the things I talk about in the real world when you're dealing with folks such as nation state actors. Again, if I was in charge of an intelligence agency, I would absolutely have my agents creating compromised modules, and then I would absolutely have them on Stack Overflow and Reddit and all of these other forums, just kind of slipping into the comment section. Oh, I see you're having a problem, I don't know, encoding video files. I found the best video encoding module out there is, and then get you to install that onto the system, right? Again, it's something to be thinking about, like with artificial intelligence, right? Artificial intelligence is a big deal right now. There are a lot of college people out there. There are a lot of folks that are creating modules and packages for artificial intelligence. And again, it might not be official from Microsoft or something like that, but it might also be high quality, right? If you're thinking about creating, again, I'm creating an autonomous robot. I'm thinking about creating an autonomous robot. Somebody out of the University of Ontario created some kind of package in order to do route planning or whatever else. I install that onto my system, and oops, it also tracks a whole bunch of other things. Not only does it plan my route, but it sends all that information to the NSA too, right? This is the kind of crap you have to be careful about. Like I say, that was a real world example of that hacktivist who decided to compromise their own module so that their module would figure out the geolocation of the server that it was installed on, and if it was in Russia, it would wipe out the server. You really, really, really do have to be careful about this. When we're dealing with the modules, again, just a quick reminder, if you just want the function, you do from random import what the function is, right? If you want, basically, you just want to import the module and then call the functions later, you do import the module, and then when you're calling the functions, it's random, or whatever the module is, dot the function that you're calling. Again, if you want all the functions and just want to be able to call them by the name, from module import all. Again, horrible idea. Don't do it, but it is possible. There might be reasons to do it. And again, aliasing, import random as whatever name you want, and then from there you can call that name dot the function that you're looking for. And that's what gets you the results, the functionality that you want. Again, with pip is simply the package installer, the package manager for Python. It's generally the ones that's used. Again, pip was initially supposed to be for Python 2. Pip 3 is for Python 3. Python 2 is supposed to be dead. I guarantee you, if you're dealing with the enterprise world, you will find it in your environment. So you run into this weird problem is sometimes if you call pip, it'll actually be pip 3, and sometimes if you call pip, it'll be pip 2, it'll be for Python 2, and sometimes you call pip and it'll fail. And so again, the exact pip command that you use will depend upon your environment. Pip 3, basically if you're doing Python 3, pip 3 install package will install, pip3 list will list all the packages, and pip3 uninstall package will uninstall the package. The final things there is, do remember, if you use the sudo command before pip or pip3, that will actually install with different permissions into a different location than if you simply do pip3. So do be careful with that. Again, some people are like, I'm just, by default, I'm going to install everything as root. And then you do, and things don't necessarily go very well. So be careful there. And then the final thing too, again, like when you're installing frameworks, again, OpenCV, Django, other large frameworks, sometimes you can install those using pip3. So pip3 install whatever, and it will install the framework perfectly onto your computer. Again, it's computers. Sometimes it won't. So sometimes you do sudo apt install, whatever the framework is, and that might get you to where you're going. Again, some of this is troubleshooting, and that's one thing too with if you're going to be doing this, again, with Python, with any programming language technology, is find a system. Again, I don't care whether it's Mac, I don't care whether it's Linux. I would recommend it's not Windows, but you do you. And just kind of stick with it, right? Because every system has quirks. Every operating system has quirks. Every hardware has quirks. Every version has quirks. Everything has a quirk, right? You are not going to find a system that does not have quirks. What you will do is you'll learn all the quirks of your system, and then when those quirks pop up, you'll be able to deal with them, right? So one of the things as you're learning this, I would highly recommend you have one lab computer and you use that lab computer for all of these classes and to learn. And then once you feel comfortable, go use somebody else's computer. And then when it doesn't work properly, you'll know it's something with the computer, not something with your code, because you're comfortable with your code. So there you go. Anyways, some additional thoughts to give you today. So as always, I enjoy teaching this class. I don't know. I think Peanut had a good time sleeping through this class. I guess we'll see. I enjoyed doing it. And anyways, we'll see you at the next one.